This presentation will focus on the technical aspects of the Nancy project. Nancy creates a blockchain-enabled radio access network architecture for 5G and beyond. Starting from the challenges of 5G and 6G networks, Nancy focuses on providing decentralized and secure wireless access, improving network resource utilization and computational infrastructure exploitation, and recruiting additional players from different backgrounds. To address these challenges and realize the Nancy vision, we leverage blockchain, AI, and MEC to enable secure and intelligent resource management, flexible networking, and orchestration. This way, Nancy combines trustless single-operator networks into a larger shared multi-operator ecosystem. The Nancy vision is based on 3 pillars. The first pillar is blockchain-enabled RAN, with its main objective being to design a novel RAN that supports dynamic scalability, high security, and privacy. This objective is realized by enlisting the following technology enablers. Specifically, blockchain, post-quantum cryptography, quantum key distribution, cell-free access, and smart pricing mechanisms. The second pillar is intelligence, and its objective is to transform networks beyond 5G to intelligent platforms integrating ultra-reliable connectivity and high-energy efficiency. This is achieved through intelligent orchestration, virtualization, optimization, a self-evolving AI model repository, XAI, and semantic communications. The final pillar is focused on multi-access edge computing, and its goal is to provide almost zero latency and high computational capabilities at the edge. In order to achieve this, Nancy utilizes offloading, caching, anomaly detection, self-healing, and self-recovery mechanisms. By fulfilling these objectives, Nancy will open the door to the following benefits. Cost reduction by enabling a multi-vendor environment that creates competitive pricing and reduces reliance on specific operators or vendors. Enhanced flexibility and scalability in the sense that consumers can transform to operators and network operators can deploy and scale their infrastructure more flexibly. Improved network performance and efficiency by enabling dynamic resource exploitation and optimization. Diversity and security through blockchain, through PQC and QKD, and by avoiding dependence on a single vendor. Interoperability by supporting both 5G and O-RAN deployments, and by ensuring that equipment from different vendors can work seamlessly together. Environmental sustainability with a focus on virtualization and energy-efficient technologies. Lower carbon footprint through reduced physical infrastructure and optimized resource usage. These benefits will be showcased in 3 usage scenarios. The first scenario is front-haul network of fixed topology and is divided in 2 sub-scenarios. Specifically, direct connectivity between a base station and a user equipment and cooperative multi-point connectivity, with both base stations belonging to the same or different operators. The second scenario is advanced coverage of mobile nodes. It is divided in 3 connectivity cases. Multi-hop connectivity, where the first hop is between the base station and intermediate user, while the second hop is formed between the intermediate and the final user. Ad hoc mesh connectivity is set up automatically when a user requests access. Point-to-multipoint connectivity is realized when one device serving multiple devices at the same time. For instance, a base station or an intermediate UE that is connected with 2 or more final users. The third scenario is advanced connectivity of mobile nodes and is split in vehicle-to-base station and vehicle-to-vehicle connectivity in order to enable mobility management. These scenarios were used as the foundation for requirement analysis and preliminary design of the test beds and demonstrators, as shown in the slide. In order to support these usage scenarios, the Nancy architecture was defined. O-RAN was used as the foundation, and on top the various technologies and modules of Nancy were designed. Initially, the interoperator domain was designed with its core component being the blockchain. To support its functionality, the Nancy marketplace was created along with quantum safety mechanisms, smart pricing, and cell-free access mechanisms. The decentralized blockchain, along with the marketplace, were created to support ID management, access control, and multi-operator service provisioning. QKD experiments and simulations were realized, and PQC for secure communications and the blockchain wallet. Cell-free access approaches with support for ID management allow consumers to transform into providers and support heterogeneous networks with dynamic topologies. The Nancy Smart pricing policies that aim to reduce cost of ownership and provide monetary incentives for new players. These components enable us to securely extend service provisioning in BRAN systems to multiple operators that are interconnected through the interoperator domain. This moves us to the second pillar that aims to intelligently manage network and computational resources. To achieve this, Nancy realizes a plethora of AI-enabled components. Specifically, the AI orchestrator monitors available resources and enables dynamic slice creation and resizing. Nancy also develops an AI model repository that registers and triggers AI or ML workflows, monitors metrics, trains, deploys, and stores the models. The AI virtualizer monitors and exploits underutilized resources, while a variety of RL optimization engines contribute to the intelligent operation of the Nancy ecosystem. Finally, for the second pillar, the XAI framework explains the decision-making of Nancy components in order to increase trustworthiness and transparency. Last but not least, to realize the third pillar of Nancy, computational offloading, user-centric caching, as well as anomaly detection, self-healing, and self-recovery mechanisms are developed. Computational offloading adjusts the placement of VNFs based on available computational/mech resources to ensure sustained performance and avoid communication outages. Nancy develops caching mechanisms that predict the content that may be requested by the user and pre-cache it to the edge, thus reducing latency and streamlining system performance. Finally, anomaly detection, self-healing, and self-recovery approaches are realized to identify anomalies at network and edge level and dynamically reroute traffic to ensure adequate performance. For being up to date with the latest Nancy developments, visit our website and follow us on social media. Thank you for your attention.